symbolic link. You have maybe heard them called soft links or symlinks. It's pointers to another file or directory, which we call the target. And they are useful both because it makes it easier. You avoid using a long path each time you change to a directory, like a project directory. And it's also useful because you avoid changing any hard links there may be in other scripts or programs. Maybe they have hard coded in a path to a library. And so your program that you are installing, it uses a library that it assumes to find. Maybe it's called libcoolness.a. It's not, and not libcoolness 2.0.a. This is very common that these libraries, when you download them and install them, they will have a version number in them, for instance. And instead of renaming that and copying it to whatever directory it thinks it's a good idea to put it in, or just renaming it, you can just update a symlink instead of it. And then you also don't have to change it in the program you installed, because maybe there are lots of instances where it's using this name here instead of this name. So you do that. And another thing, you may have heard them referred to as soft link. Is there also a hard link? And yes, there are. They are also shortcut for files, but not for directories. But they cannot be created for files in a different file system, so that's the difference. We'll look at them a little bit more in a little short while. So to create a soft link, symbolic link, you say ln-s, the real file, folder, or library, and then the link name. If it was a hard link you wanted to create, you just said ln, the source file, and the linked file. To see, to verify a soft or hard link, you can run ls-l source and link. And let's do some examples. And you can type along to this if you want to. I'm still using this directory here. And you could either use the files in redirect in the link, or you can create a file to play with. You can always create a test file doing something like this. So that will give you a test file with the content in it. So if you want to create a hard link, then you would say ln and test file. And then let's just name it link file. In this case, it's not going to do a lot of good, but we now have it. We have link file and we have test file. And let's see what happened. It should spell right. So now you are listing both test file and link file. And we are looking in the long form. And we are also using -i to see the inode. And you can see here that the inode of those two, it's the same. And an inode or an index node is a concept in Linux. Each object in a file system is represented by an inode. And it's simply a data structure that stores basic info about files. And you can read more about them here. But if the inode is identical, then it's the same file. So let's try and create a symbolic link to a directory. And we can do that with ln-s as we saw. So let's do ln-s. And we could take the path to this directory. An easy way of getting this path is with pwd. And then we are creating ln minus s. We are copying this path here. And I neglected to actually name it, sorry. I'm going to put it in my home directory. Bash X. Because I probably already used this one earlier this year. This will create a symbolic link, in this case now named bash X, in my home directory. And let's try and go and see if I have something called bash X. I do indeed have that in my home directory. And as you can see here, bash X is pointing to this place here. And I can say cd bash X. And I'm now back in this directory where I was before. So what if I wanted to create a symbolic link to a file in the same directory as the file? Sure, I can do that. There's nothing problematic in that. And that's, for instance, what I would do if I am renaming this libcoolness2.0.a to call libcoolness.a so that my program finds it. So I'm just saying ln minus s, and then I could give the full path. In this case, it's not necessary, but sure, let's do it. And then I am simply putting it here. And you can see I now have libcoolness.a there. This one I created previously because I neglected to name it. That was my fault when I created it in my home directory. But libcoolness.a is pointing to libcoolness2.0.a. So that's fine. Now my program will find it. And I could also do it for something in a different directory. Imagine that your program looks for it in user lib, and you installed it and it ended up in lib64, user lib64. Well, you just put a symbolic link there. That will work. Remove a symlink. You can remove it either with onlink or with rm and the path to it. The main benefit of a remove over onlink is you can remove multiple symlinks at once, like you can with files. So we could say remove libcoolness.a, and then it's gone. And you could also have used onlink, but then you can just do it for one. And one thing to mark here is if you're removing a symlink to a folder, do not include the slash at the end, since bash then will think it's a folder and you cannot remove a folder directly. But a symlink is just a file, which you can. Okay, it's now 5:15 or even 15:01. It's time to have a break.